All right, we are Team Tungsten Nebula, working with Iron Galaxy, and this is our Sprint 1 milestone presentation. The game we're working on is called PhotoShootOut. It's a fast-paced, local multiplayer action arcade game about taking amazing wildlife photos. I'm Aaron Solon. I'm the producer, designer, and programmer.
I'm Antonio Vasquez, and I'm the level designer and narrative designer.
I'm Emma Christensen. I'm a 2D artist and concept artist.
I'm Lia Fry. I'm the 3D animator and artist.
Hi, I'm Xiao Ma. I'm a 3D artist.
I'm Jonathon. I'm a programmer.
Hey, I'm Ben Person. I'm a UI and UX programmer.
Hi, I'm Sadeem Boji. I'm also a programmer.
The game is a top-down action game where the players move around the screen tracking AI-controlled animals and taking pictures of them. The game features a very cool diegetic photo mechanic where when you take a picture, the image prints out in real time on an in-game Polaroid that's displayed in the UI to the players. So you can sort of see, the image that you create as you take it in the game. It's also going to feature fast and fun movement, and we have a focus on chaotic gameplay punctuated by quiet moments where you capture the perfect photo. All right, so now we're going to jump into a quick demo of our progress in Unity. So the first thing I'd like to show is our progress on the player character. So in this test scene, if I use input on a device, it's going to spawn a character for me. We have the basics of the character in place, so I can move around, I can dash. I'm on keyboard and mouse here, so that's on right click, and I'm using WASD to move. And I can take a photo with left click. So that'll appear in the UI based on the direction the player is facing, and I got a little glimpse of that moose walking away there. We also have the basics of multiplayer set up. So if I give input here on my Switch Pro controller, it's going to give me another character for that input device. It does support up to 4 players at once, and you should be able to do all the actions regardless of what type of device you're using. So here on the controller, I can dash around the same way. I can take photos with the button here. That one wasn't so great. Oh, they're all right. So that's all in place. We also have started the very beginnings of implementing sort of in-world interactions for the player controller. So this little thing here is a prototype geyser that can shoot this character into the air when they run over it. So we have the code in place to do things like that. If there's a little more elevation, maybe I could jump up onto a cliff here or something using that. Moving on to talk a little bit about the animals. I'm going to switch to scene view here. We have started to implement our moose. So as you can see here, we have the mesh made by Xiao. Emma textured it, and Lia's begun to animate it. So we do have the basics of an animation controller going with a simple walk move here. And John has implemented the start of the AI for the animals as well. So they'll wander around the map. If they're hungry, they'll go to a food source, a plant for them, and eat it. That's what the green box signifies. Here, this little blue debug box was showing that he was drinking, so he came to a water source. Now he's going to eat. And after they've moved around the map for a while, they'll move to the edge and exit, which I think is maybe what this guy's doing. Yep. So as we continue more, we're going to make it so these AI react to what the players are doing. That's the next step. And also react to other animals, as we discussed before. So that's moving along very quickly, and we're super happy with the overall progress on the animals so far. We've also begun to familiarize ourselves with ProBuilder, which is a level design tool. So Antonio's been learning the ropes on that and built this basic testing area. And we'll iterate on this and get a more advanced level as we get more of the gameplay mechanics in place. So far, I would say we're moving along pretty quickly. Really happy with how far we are, and prototyping at this rate has already started to give us some useful insights. For example, we noticed that it can be hard for the player to tell where the animals are just from their regular gameplay views. So that's telling us that we need to add some kind of additional UI or indication or easier way for them to find the animals so they can go and take pictures of it. But yeah, in the coming weeks, we're gonna develop this further, get it to a fully playable prototype with with scoring and some more mechanics and so on, and really get a more of a feel for the game.
All right, so now we are moving into
the design progress portion of the presentation. So first off for design progress is the sprint goals. Now, the goals that design had for this sprint were threefold. The first was choosing a tentative direction for the game, as we had a lot of ideas, but we wanted to put them together into a cohesive concept that we could then prototype. The second was document the systems in a clear and concise way so that the team could all be working on the same page and with the same idea in mind. And then the third was prototype a level blockout. As you can see here, one of the things that we had that we wanted to look at was our camera mechanic, and this is a little sketch of something in our documentation. For the progress we made this sprint for design, the first thing was the team settled on what we wanted to do for the first prototype, which ended up being the camera photo shootout concept that we looked at. We're looking forward to actively playtesting, and we might still pivot on how things go. However, we settled on this first idea and something that we could playtest, so then we can see whether or not the mechanic is fun and whether or not we want to continue with this going forward. We created a lot of documentation, multiple pages detailing systems and AI and player controls and overall mechanics of the game, so that the team had a master set of documents that we could look at for what things needed to get done. And then we communicated with the rest of the team to get those things that we wanted and that we had documented implemented within the game. And then the last thing, as far as major progress goes, is we used ProBuilder to make a basic level blockout to prototype in, utilizing ProBuilder to make some basic environmental assets as well as the level itself, so we could test how the level interacts with the AI and with the player itself.
Up next, we're going to go over some art progress.
One of the biggest goals for art this sprint was to create environment, animal, and player concept art, as well as texture the moose that Xiao made. As you can see on the slide, there are several sketches of animal character art, as well as an environment concept piece in the lower middle and the moose that was textured in the lower right. The art team decided on a low-poly geometric look for the game. We want to keep the environment blocky and simple so that we can put more time and energy into making the animal character art really stand out and pop against the background. One thing I'd like to change going forward is to add more color to the sketches that I make so that I can reference them when I'm texturing the animals in future sprints.
Hi guys, now it's model part. For this sprint, our primary goal is mouse. Our art style is low poly. Here is our first version mouse. Now it has 99% look like the mouse, but I still need to modify. During Lia's reading and animate mouse, she helps me find a lot of some points need to change and give some suggestions. So I can improve on the mouse, and the left time I also will draw on it. And we have a great teamwork and plan. I'm so happy on this point. Besides mouse, I also made some simple environment assets. Use cube and corn to build grass. Although it's simple to load it, but it makes sense with our low poly art style.
The last bit of art progress is on the animation side. Before we even had a working model or anything, I first set some goals in terms of research. I started by watching some other tech artists and how they approach working animals, and then looked more closely at moose anatomy and other moose rigs to get a sense of where I needed to start for my work. So this is the first iteration of the moose rig. After receiving some feedback on it, I will be going back and fixing some of the mistakes and also adjusting it for the next version of the model that Xiao provides. I also compiled a list of animations that I'll be aiming to accomplish throughout the semester, while also noting the animations based on importance for the game, such as like a walk cycle will be more important to see than an animal doing something super specific. And then my next steps are polishing the rig, and creating an animation tree in Unity, and creating and plugging in some of those basic animations, such as walks and idles.
Now we're going to go over the code process.
We started work on the player controller. So right now we have, with the new Unity input system, to allow players to use either keyboard and mouse or different kinds of controller. We have moving, just normal movement, left, right, up, down, dashing. So if the player's moving, they can sprint a little bit, and potentially in future, as we're developing next last few couple of mechanics for our first playable for next sprint, tackling a player with a dash to steal photos from them. And then also we've been working on getting the character to be able to take a photo. So right now, all those basic movements are set up and usable in our test environment. And then also we've begun prototyping various elements of the UI. In particular, we have a basic timer set up for tracking whether or not the game is running or not. So it's roughly 2 minutes, 30 seconds. When it hits 0, the game is over. And we have a player UI to denote how many photos a player is currently carrying.
So on the AI side of programming, what we wanted to get done is we wanted to set up an initial state machine for AI control. This state machine would have behaviors that are based on a probability and stimulus-based state transitions for things such as vision and sound of an animal. We also wanted to set up a baseline for the behavior of the AI that can be adopted by other animals later, so we don't have to code it all up again. And for what we actually were able to get done is we were able to implement all probability-based behaviors on our first animal, so we were able to get done feeding, wandering, leaving, and drinking. And from that, we were also able to set up a base state machine on the moose that can be inherited by other animals. So again, we don't have to recode all these behaviors again. And for what we're going to need to address going forward, AI takes a lot of time and testing to get right, because we need to bug test it and also just play with it a lot and tweak all the values until it feels good to play with. So it's going to take a lot of work in that front to get it to feel really good if we want to. And we'll also need to set up systems for stimulus-based transitions in the next sprint for things such as sight and sound, just so that animals can react more actively to what the player is doing. Along with this, we're going to need to consider things such as optimization for the AI, because if we're sloppy with that, things could tank really quickly. And we also need to consider the scope of the AI, because if we want to add all these small interactions, and while they would be really cool and add a lot to the game, if we go too overboard with that, we could end up with messier AI as the final product. So it's just something to keep in mind.
For our main mechanic of the game, we were able to prototype a working camera that the player can use. It lets you take photos from a first-person point of view when the main camera is top-down. Our next goal is to find out how to register what's in front of the camera so we can score it and grade it. And in the future, we want to make the camera more complex with different angles and be able to support the player going on slopes. Thank you for watching our presentation.